another Leetcode Daily, and today we have redundant connection. This is one of these questions that it would make your life a lot easier if you know a certain algorithm. Um, yeah, that algorithm is union find. We'll get into this one slowly, and I'll explain what union find is and hopefully explain the solution. It says, in this problem, a tree is an undirected graph, so there's basically directions back and forth that is connected and has no cycles. You're given a graph that starts as a tree with n nodes, from 1 to n, with one additional edge added. So there's an extra edge in this graph. The added edge has two different vertices from 1 to n, and was not an edge that already existed. So basically, there's certain edges that were added, and then there's a redundant edge that got added extra. The graph is represented as an array edges of length n, where edge AB indicates that there's an edge between node A and node B, right? It says return an edge that can be removed, so the resulting graph is a tree of n nodes. If there are multiple answers, return the answer that occurs last in the input. So basically, if you look at this, there's a redundant edge there between 2 and 3. Any one of them can be the redundant edge, but because 2 and 3 was lost in the thingy, in the array, that's why it's the one picked. Here, the same goes for 1 and 4, because it goes last and is redundant. So this takes us into how to solve this problem, right? Okay, so you can solve it with different ways other than union find, but union find is definitely easier and straightforward. You can actually just do a DFS and look for connections that appear again. But union find is an algorithm where it's called disjoint set, where you're grouping certain nodes, basically dividing them into teams, and every team has a leader. That's basically it, right? If these nodes were not connected together, there would be several teams where every team would have one parent. It's called the parent. And the rank is the amount of nodes in that team, basically. So let's say this example, right? We would have a team where the parent is 2, for example, right? So 2 would have all these nodes in the same team. The thing is, we can leverage the union find to actually to get the redundant connection, because once union find is divided into two methods. One is called find, one is called union. Find basically takes a node and gets its parent. So basically, when you want to add a node to a team, you have to get its parent, the one responsible for it, right? And then you get the one responsible for it and the one responsible for the other node. So basically, if 1 and 4, you get both parents, right? We get the parent of 1, parent of 4. What we do is we're going to check who is the bigger team. We want to join the bigger team. In this case, let's say, for example, it's 1. So all of 4's members, like his parent and any member that belongs to 4, joins 1, basically. So that means we union them together in a way. So speaking again, if we go through these edges and start doing find, which gets the parent of every vertex, and then union them together, we're bound to have an index in edges where, for example, 4 and 1, 4 already has a parent of 2, for example, and 1 already has a parent of 2. That means this connection is redundant. Since they both belong to the same parent, they were both processed before. So that edge is useless. That edge leads us to nowhere. So let's start, for example, dry running this. Let's say 1 and 2. So let's say we union find these together, and then the parent of 1 now is 2, right? 2 and 3. The parent of, let's say the parent of 3 now is 2 as well. So 2 owns 3 and 1, and then goes 1 and 4. When we want to union them together, we get the parent of 1, which is 2, the parent of 4, which is also 2. So they belong to the same parent anyways, so this connection is redundant. It's not going to benefit us in any way. And then we go through 5 and 1. 5 belongs to 5 because it's not yet assigned, and then 1 belongs to 2, so we join them together. So basically, this is the easiest way to detect the redundant connection. This is a way where we recursively find, it's iteratively in this case, but we try to find the parent where we have a parent array, which every index starts with its own. So I'm my own parent until I find one. And then a rank, which is just one for every start. Like it begins as a single node, and then we increase accordingly. Find basically starts off as temp. If it's not equal to the parent, uh, if it's not equal to the parent, we recursively find it until we find the parent, and then we're gonna be unioning both parents together. So this is the case where we return false if both parents are equal. Otherwise, we're gonna check who's the bigger team. We're gonna add the smaller team to the bigger team. We're updating the rank, and then we return true, right? Now we just iterate over the edges. The second we find an edge that returns false, redundant, we return that edge. That's as simple as that. The time complexity for this is, I think, in our case, probably O of n plus v, where v is the edges and n is the vertices, or like v is the vertices plus the edges count, because yeah, it's n plus v. That's the time complexity for this. Thank you guys for watching, and see you.